Okay, guys, this lecture will be about the nerve cells in the anterior horn. So I already prepared the sketch note here, and so I will not take too long. It will be fast, even better in my opinion, because we can focus on the topic. So nerve cells in the anterior horn. Anterior horn. Okay, so we have here the nerve cells in the anterior horn, and the anterior horn contains two primary types of nerve cells: the large anterior horn cells and the smaller gamma cells, which I will show you here. And these cells will be important especially for the motor control. Let's start with the axon of the anterior horn, this one. Axon of anterior horn. Okay, so this axon extends to innervate the skeletal muscle. Okay, not only one muscle, but group of muscles sometimes, and facilitates voluntary muscle movement. So here we have the skeletal muscle. Okay, here we have the skeletal muscle. The extension of the cell, innervating the muscle. Coming from the anterior horn. Okay, let me just finish the spinal cord here. Here we have the spinal cord. Anterior fissure. Posterior horn. In another video, we're going to talk about the lateral horn, okay? About the cells of the lateral horn. And then we have here the anterior horn, central canal. These are the gamma cells. Oh, don't fail now. Gamma cells. Okay. Here. The gamma cells will contribute to the regulation of muscle tone, especially influence the activity of the neuromuscular spindles. Here we have the gamma cell. The axon of gamma cell. This is the axon of the gamma cell. I will highlight this part because otherwise we'll be confused. So the axon of the gamma cell will innervate the intrafusal fibers of the neuromuscular spindle, and it will help with the regulation of muscle tone and proprioception. Okay, especially here. So axon of gamma cell. Okay. Oh, this is the anterior horn. This is the anterior horn. Okay. And then the neuromuscular spindle. Okay, here we have the neuromuscular spindle. The neuromuscular spindle is actually a sensory structure within the muscles that provide feedback on muscle length and tension. Neuromuscular spindle. And then here we have the skeletal muscle. Skeletal muscles are the target tissues for the signals transmitted by the anterior horn cells. So here we have the skeletal muscle. Okay, let me just add some extra thing here. The anterior horn cells, okay, or anterior horn cell, will be responsible for generating the neural impulse that control skeletal muscle contraction. Okay, control skeletal muscle contraction, innervates, okay, this one contributes with the regulation of muscle tone, the gamma cell. Okay, the axon of gamma cell innervates the intrafusal fibers of the neuromuscular spindle, helping with the muscle tone and proprioception. The neuromuscular spindle is a sensory structure within the muscles that provide feedback of muscle length and tension. Then we have the axon of anterior horn, that will extend to innervate the skeletal muscles, helping with the voluntary muscle movement. And then we have the skeletal muscle, which is the target tissue for the signals transmitted by the anterior horn. So what I'm gonna do now, I'm gonna use the yellow here in this area, and I'm gonna do this. Okay, anterior horn. Let me just do this. Anterior horn. Okay, what else? Clinical information about this area. So, for example, before I do this, I want to mention something. Just to, I want to add something just to keep more clear. This is the topic of this lecture: nerve cells in the anterior horn. Let me just check something. Okay. Okay, what I mentioned before, this axon here of the anterior horn will transmit information from the anterior horn to the skeletal muscle, which is the tissue target, okay? So, and this will help us to control voluntary movement, like these movements here. Now, when damaged, the anterior horn, this cell in specific, what will happen is a lower motor neuron syndrome that is usually characterized by muscle weakness, atrophy, fasciculations, and hyperreflection. Okay, hyperreflection. Where you are going to see this kind of injuries, where you're going to see this kind of conditions in situation, amyotrophic lateral sclerosis or poliomyelitis. Now, the skeletal muscle is this structure here. Okay. So now if you understand that this cell controls voluntary muscle, if this cell is damaged, you will have paralysis or atrophy of this muscle. Okay? About the neuromuscular spindle, this structure here. I mentioned before that this is important for proprioception and reflex arcs. When I say reflex arcs, you can understand that is related with the stretch reflex, and this neuromuscular spindle will help with the posture and the balance. So when affected, what will happen? What do you think that will happen? So movement disorders and also impaired coordination. So this is what can happen if damaged. Yeah, good, Nina. That's it. Yeah, the brain is super complex. Gamma cell axon. This one, axon of gamma cell. So gamma motor neurons usually regulate the muscle spindle. Okay, the sensitivity of the muscle spindle, and as I mentioned before, helps with the muscle tone, especially during voluntary movements. What happened during the dysfunction of this cell? What do you think that can happen? So dysfunctions on this cell usually can lead to conditions like spasticity, where there is an abnormal increase in muscle tone. So this is something that can happen. And then we have the anterior horn cell here. I already mentioned, but it's always good to remind that disease affecting anterior horn cells, such as spinal muscular atrophy, quite often will result in progressive muscle wasting and weakness due to the loss of motor neurons. And what can happen is during some autopsies, usually was related that some cases show a significant reduction in the number of anterior horn cells. Reduction. Okay, and then we have the gamma cells. Thank you. Art. Oh, you are an artist. Great. I love it. Yeah, this is what I wanted to share, guys. What I'm gonna do, this video, the full video will be on my YouTube channel. And if you want to have a look, probably in 1 hour will be on my YouTube channel, which is the same name of my TikTok account. During the mornings, all the content here will be related with clinical anatomy and in English. Afternoon will be in Portuguese, just to remind you. So afternoon will be in Portuguese, and I will cover other topics like nutrition, health and well-being, Chinese medicine. So this is what I will be covering during the afternoon. I have a background in sports and science and physio. I also have a training in Chinese medicine, my background. Currently, I'm finishing my master degree in clinical anatomy. So for 1 year and a half, I was demonstrating and teaching clinical anatomy to the first and second year of MBBS. So yeah, this is my background. Yeah, thank you. So every morning at 9:30 a.m. I will be here, UK time, okay? So I'm gonna finish the live now. I really appreciate your time here with me. I hope you enjoyed the topic and that makes some sense for you understand of the nerve cells in the anterior horn. Tomorrow I'm gonna talk about the nerve cells in the lateral horn. Oh, great, thank you. Tomorrow, lateral horn, and then tomorrow is Thursday, and then on Friday, if I have more time tomorrow, lateral horn and posterior horn. Otherwise, will be lateral horn tomorrow, and on Friday, posterior horn. Anterior horn, lateral horn, and posterior horn. Let me show you this one. Lateral horn, posterior horn. Okay? Thank you so much. Thank you for sharing this, sharing my life. And tomorrow I will be back. And if you have any question, or any suggestion, please, you can drop me a message because I will have a look at it later. Okay? So I'm gonna go now, and I'll see you tomorrow again. Bye.